The main result of our new paper is that we are able to place constraints on the masses of 3 newly detected planets orbiting the nearby star GJ 9827. The constraints come from data we already had in hand from a long-term radial velocity survey we are conducting with the Planet Finder spectrograph, an instrument on the Magellan 2 telescope. I could make a whole other video about how we made those measurements, but here I want to focus on what the results mean. Here I'm drawing a diagram of the radii and masses of planets detected around other stars, known as exoplanets. Mass and radius are two fundamental parameters that we can measure from observations of exoplanets, although for only a fraction of them do we have both measured. The vertical y-axis has a linear scale, while the horizontal x-axis has a logarithmic scale. See how there's about equal space between 1 and 2, as there is between 10 and 20? The magic of log! Now, what does this landscape of mass and radius look like when populated with the planets we know about so far? Here, each black dot represents an exoplanet for which we have both mass and radius measured. I'm guesstimating here with the spacing. You can see our paper for the plot with exact values, but you get the idea. In reality, each of these black points has error bars associated with it too. The really cool thing about mass and radius is that, from those values, you can calculate the bulk density of a planet, and from that get an idea of the bulk composition. The colored curves I'm drawing represent what mass and radius a planet would have if it had a certain bulk composition. Again, this is a sketch, so my curves aren't perfect, but you see how just these two fundamental exoplanet parameters alone already tell us a lot about the kinds of planets there are in the galaxy. The planets around GJ 9827 were discovered via the transit method, which measures an exoplanet's radius. But to put those planets on this plot, we needed masses, which we got from PFS. The arrows I'm drawing to the left for the mass error bars for planets D and C mean that our measurements weren't quite good enough to place firm lower limits on these planets' masses. But we did a pretty good job for planet B. It isn't Earth-like because it's super hot, but it's interesting because our measurements suggest it's also super dense. PFS was the first to constrain the GJ 9827 planet masses, but we hope future observations will help us learn more about this very nearby system.